And now I would like to show you how easy it actually is to get the OPTOLUTION PIV system for PIV up and running. First, you put the camera and laser onto a tripod. You plug in one end of the synchronization cable into the camera and the other end into the laser. Then you connect the USB cable with the camera and obviously also with the computer on the other side. And then you need to connect the safety interlock with a door switch, for example, and the contact of this interlock needs to be closed to unlock the laser. Then next step is to connect the power supply and to switch the laser on, of course. And then finally you plug in the USB wireless serial link and start PIVLab. In PIVLab, then you go to the image acquisition module. You select a project folder where you want to save your images and also save your session. Then you have to select the suitable configuration. So in this case I have the 5 watts laser and the OptoCam. It is detected automatically. Then I am changing the camera bit depth to 12 bits in this experiment. I am setting the frame rate to 80 Hertz and then just toggling on the laser and starting the live image preview, which is running without synchronizer at this moment, but I just want to use the autofocus. So I'm selecting the correct lens, then hitting the autofocus, and then the autofocus starts to focus on the particle pattern that is illuminated by the laser. After that, you switch off laser and the camera again. And now we can select the pulse distance or interframe time that we want. I have found out that 1500 microseconds is a good choice for this experiment. We want to save the images and we want to capture 500 double images in this experiment. Yeah, and then I start the capturing. It asks again for safety reasons if I want to start the laser and also if I want to overwrite existing files. And then I'm just trying to do some nice vortex rings. After the images are transferred, you can scroll through the double image pairs and you can quickly do some analysis to check if you have some nice data, which is the case here. I think pretty nice vortex rings that are generated. And after that, you can do the analysis, of course, for all the images in this session, and then you can export everything, and this is how it looks like. So pretty nice vortex rings acquired with relatively high temporal resolution of 80 double frames per second, so 160 frames per second. This camera can also run much faster, up to 400 frames per second. Yeah, well, this experiment that I just set up here has pretty low requirements on laser and camera because it's small velocities, it's a small field of view. But this is just what I have here at hand now. As I already told you, with the 40 watts module, you can easily do measurements in air, also at higher velocities. But this is just to show you how simple this setup actually is.